Here I will talk about generic pointer, which is a pointer that can point to a variable or object of any type. This is also called as void pointer. Although you can use a generic pointer to point to a variable or object of any type, you cannot use it to access the data. To access the data, you need to do something called casting to a correct type. Let us learn about generic pointer through coding. I have this program to start with. Let me have a variable x initialized to 20, another variable y double type initialized to 22.22, and I can have integer pointer and make it point to variable x, and I can have double pointer and make it point to variable y, and I can use these pointers to access the data. And asterisk y dptr, and we can use the pointer to change the data. And we can again print it. So let me make sure that this program doesn't have any issue by compiling and looking at the output. So compilation and linking and execution. So it is displaying the data. In the beginning, integer contained 20 and 22.222, and then it was updated to 33 and 33.33. So we don't have issue with this code so far. Now let's talk about the generic pointer. So generic pointer is this is also called as a void pointer because the type we use to create a pointer is void. So you can define a generic pointer using this syntax. Call this. This is name of pointer, and this is the type, which is also called as a generic type or void type. I mean, particularly this is a void type, and then you put this together, that will make it pointer type. Here I can since we have two variables, so we want to make two pointers, 1, 2. So I want to make this first pointer point to this variable. I want to use this second pointer to point to this variable. So I can do that by just setting equals to address x and address y. So you can use this generic pointer to point this the variables of or objects of any type, but you cannot use it to access like this. If you try to access using generic pointer, compiler will complain. We'll see a compilation problem here. So it is already complaining. You cannot declare reference to void. I think this was a syntax error, but the main problem we will be having here is this one. It is not pointer to object type. So you have to have a pointer to object type, not generic pointer, to be able to dereference it. So let me go back to the code and correct both issues. So I should have put asterisk here to make it pointer, and then this is not allowing me to access. So to access the data through this pointer, you need to actually cast to a correct type. So in this case, this pointer is pointing to integer data, so you need to cast this into integer type pointer to be able to access. For example, if I want to display the data through this pointer, then I should first cast it to integer pointer type, and then after that you can access the data. You can do dereferencing after that. Similarly, if you want to access the data through another pointer, then you again do cast, but you need to cast this to double type because it is pointing to double type. So double type variable. So we can see the value 33.33. Let us also try to do this opposite side. So if I cast this as double and this as integer, cast to the opposite type of the type of the data these generic pointers are actually pointing to. So you can see the problem here is if you try to interpret integer as double and double as integer, then the output doesn't make sense. It doesn't appear to make sense here. So if when you do casting, then you have to cast to correct type. This should be integer, and this should be double. So you can also use that pointer to point to a dynamic memory. So this will create a dynamic memory space for byte, and which would have the value 5 stored in it, and that is actually pointed to by this GPTR1. Now again, if you want to access it, you have to do this kind of casting because this is integer type data. Then when you are using this dynamic data, or making the pointer point to dynamic data, then you need to delete. So the way of deleting is, again, you cast to the proper type and have a delete statement like this. This is the way you delete that dynamic memory space, and you can use the same pointer, generic pointer, to point to an array storing data 11 to 22, 33, 44, and you can access it in a loop plus, and then again, if you want to access it, you need to cast. But in this case, if you are using the syntax like this, GPTR1, this syntax, then you can only cast this name. You don't need to dereference in this case. So you do static casting to integer pointer, and then you use this operator to select the element. So this is the syntax you would be doing, and if you want to delete this array, then again you have to follow the same thing. You can do use this kind of statement, but you need to put this bracket here because this is an array. Let me make sure that this program compiles. So it is compiling, it is displaying the integer data, and it is displaying the array. Here I will discuss a programming example to demonstrate the use of a generic pointer as a function parameter, so that the function can be called with a pointer or with a data of any type. Let me do it through coding. So first I want to have, let me have a variable int x equals to, let me have 18190431144. So I would call a function called print and pass this into a pointer. Print, and I can receive this as a into a void pointer. But if I don't intend this function to make any changes, then I can make it constant and call this gptr. So I will be calling this function by passing address of x. So this address would be actually assigned to this pointer. So this pointer is pointing to the integer type data at this point, and inside what I want to do is I also want to pass, let me have OSTream object passed, and I want to use OS object to display the data. And also let me return it, and I want to have return type OSTream reference. So we have this function, and I cannot display like this. You need to cast to appropriate type in this case. So you cast, if you know the appropriate type, then you can just hard code it, cast to constant integer pointer and display. So let me make sure that this code works, then I will do expand it further. So we have an issue. Oh yeah, I think in the calling, when I was calling the function, I should have also made change. So I should be passing cout object as the first parameter, as first argument, and when it is done, we can make use of this the fact that it returns. So we want to insert new line character, so that whatever is displayed after that, it is going to be new line character inserted. We can use this because this invocation actually returns cout object through this return type on return statement. So I think I should be able to compile now. Let me go back to the terminal. So it is displaying that data, right? Now if there's only one data to be passed, then there's no point having void, right? So you can have only int. So you want to make you want to use void so that the function can be generalized to be, it can be used for different type of data. So for example, if I have another variable y equals to 2222, then I should be able to call this with the address of y as argument. So in this case, I also want to make use of it. The thing is that the challenge here is that how do you determine this appropriate type or correct type, so that you can cast this pointer into. So you need to actually pass that information inside here. uh, Maybe for that purpose we can create an enumeration. Maybe let us have something called a scoped enumeration class, and data type or something, or you can call variable type. It could be integer, it could be character, or double. I cannot use this keyword, so I need to add something here. Call this double precision. So we have this enumeration type, and we can use that enumeration type um, uh, to pass. So we need additional parameter here to receive that type. That type, and then inside you can use the switch type. If the type is, let's say, type integer, then you do this kind of casting. And break. So it could be double type, constant double, and display, right? So let me keep it this much now. So I can I should now, when I call this function, I should also pass this type. So it's going to be, this is a class scoped enumeration, so you need to use this in this form, name of the enumeration followed by scope resolution operator, and then this values here. So here in the first case I want to pass integer, and in the second case I will pass double. So let me try, sorry, this should be double precision. So let me again compile it. So it is a warning. Okay, I think I can ignore that. It is displaying the data the way we expected. So so much it is working. And if I want to, let's say, a little bit different thing, instead of this simply passing this values, if you want to pass something like an array of character, something like this, right? So in this case, this parameter will accept the one pointer to one data. If I want to pass this text, I would be passing the address of the first element into it, like this. So if I pass address of, just text, because in the case of text is itself is an address, it is a pointer. Either you do like this or you pass it like this. and then it's going to be character. We already have character in our enumeration, so we can use it. And here we can have so it's going to be character pointer. So if I do this, it will display the character, but I think I suspect there would be one problem here. So let me first see the problem. So it is displaying its let me assume that it's not a problem. I mean, I think there is a problem, but it's not displaying there. So since it's not displaying, I will assume there's no problem. So if I want to display all these things, then I would be passing in the case of character, if I remove this, I think let me try with this. So I should be this should actually display the entire string. So now you can see the entire string is displayed. But if sometimes if you want to pass, let's say, not a single item, if you want to pass maybe if you want to make this code generic enough, and you may want to pass an array, not like this, or it could be array containing multiple data items. Like this. So in that case, what you can do is you can also pass another data which represents the number of items you want to pass. In this case 3, and in the second case also 3. In the third case, how many characters you want to print? 1, 2, 3, 4, 5. So, and then if you have that situation, then maybe you can put this in a for loop. You want this function to receive that data. So int size or something, and for int I equals to 0, I less than size I plus plus. So I think this should be it, and for default you can just simply break it. Let's see the output here. So it is displaying, but I think there was one small issue there. I need to go back and fix that issue. I actually need to select the, because this is a pointer, right? So either you do something like this, I, or you actually increment it plus I, and then after you increment you do dereferencing after that. So So you can see the data displayed first. I think it was 144, this data, and then after that we have another data and some other data here, and these numbers are displayed 2222, 33, 44, and then this characters displayed here. So this is an example which demonstrates that you can use void pointer to pass different type data into it and handle it inside. Now let us see how we can use the generic pointer to point to a function. First, to learn this topic, you need to be familiar with something called function pointer. So for that purpose, I am creating a function. Suppose we have only one parameter, and we actually, to do the summation, we need at least two values. So maybe what we can do is, let me have a global variable, some base value, and I want to actually add this on the top of this 10 and display it, summation of and x plus a, right? So this is a function I'm dealing with now. So if I want to use a function pointer to point to this function, I would be creating function pointer using its type, right? So in the case of integer pointer, I would create integer like this, right? But in the case of function pointer, the syntax is a little bit different. You need to do something like this. You have a return type first, void, and we have parentheses. Inside parentheses you put asterisk, and then after asterisk you actually, like in this case, after asterisk you have a name, so you have a pointer name fptr1, and then after the parentheses you have another parenthesis which will enclose the types of the parameters. In this case only one parameter and type is integer, so you just put integer here. So this statement will actually define a function pointer fptr that you can use to point to that particular function, equals to sum1, right? So this is this is for creating a function pointer, and this is for making it point to that function. You can also do it like this. You can also put this character, so but I am not doing that here. And if I have another function receiving two data, sum2, int a, int b, and a plus b, and when we invoke this to differentiate, to identify which function is being called, we can put a small text here, one parameter function, and here two parameters. For that function, or for a function of this signature, return type and number of parameters and types of the parameters, you cannot use this pointer to point to that function. You need to create another pointer with the corresponding type, right? So you create that function to point to that function, pointer to point to that function using this syntax. This is going to be the name of the pointer, and you have two parameters in type, so int, and you can make it point to sum2. Similarly, if I have another function with 3 parameters, two parameters, but this function actually returns integer type data, the summation. It displays and also returns 2 and 1 return. It only displays this text and we will be returning that data. Right, so the purpose of this text is to just to identify or to know whether this function has been called or not. So for this you cannot use this pointer because return type is different integer, so you need to create another pointer, int fptr3 int fptr3 equals to sum3. So now we have 3 pointers pointing to 3 functions, and if I want to use it, I can do like this. First function does not return anything, and you can just call it like this, fptr1, and then pass the data you want to, argument value 6, and in the second case it is fptr2 and 2 values. In this case this is 7 and 8, and in the third case the function actually returns data and you want to use that data, so put it in the cout statement, fptr3 8 and 9. So this is the uses of this function pointers. Let me first compile and make sure we don't have problem with this code, and then I will explain how we can use a generic pointer to point to these functions. So compilation and execution, compilation and linking and execution. We have, in the first case it is 16, 15 printed, and 17, right? So it is working as we actually expected, or as it should work. Now if I want to make use of a generic pointer to point to this first function, I could do something like this, void pointer equals to sum1, but you cannot assign like this. You need to actually because the type of this function is different. Type of this function is this one, so you need to cast this to void type. Or you can also do the same thing through the pointer, because the pointer is already pointing to this function, so fptr1. These are equivalent things. So, and also you can have another generic pointer gptr2 and make it point to another fptr2, or you can reuse this same generic pointer and make it point to another function, gptr3 equals to void pointer fptr3. So, but if I want to call, you cannot use this as I told in the previous before in this recording, you cannot use the generic pointer to access the data from the variable it is pointing to. Similarly, you can use this pointer to call the function, so you need to cast to the appropriate type. If you want to call this function through this pointer, like in this case, you need to first cast it into this corresponding type, the type of the function sum1. So gptr1, typically you would be calling like this, but because this is a generic pointer, so you have to cast it. So here the casting, you put the type of the function, which is the void asterisk int. So this is the expression that comes out after casting, and then you use that expression as a function name, like in this case, and then you pass the argument here. Similarly, if you want to use if you want to call another function, you would be doing a similar return type void, and then we have two parameters, two, and you pass let's say 7 and 8. And again void, in this case it is return type is integer, so integer, and int gptr3 8 9. But this actually invocation returns the data, so you want to insert that into output stream, so put it like this. Right, so let us see whether we are okay or we have some problems to fix. We didn't have problem. Now it is running it 16, 15 and 17 like in the previous case, but we are actually displaying this through the void pointer and then casting to the appropriate type. And also you can use instead of just this syntax for casting, you can also use reinterpret cast in this place. This is going to be the type. So that it is working. So this was outcome of that the use of reinterpret cast, and this was another outcome of the use of reinterpret cast. Now let us learn how to use the generic pointer to pass a function as argument to another function. So for that purpose I will be using the same code that I came up in the previous exercise when talking about the use of a generic pointer to point to the function. I actually want to pass these three generic pointers into a function and display data from there. These three things. Instead of displaying here, I want to actually display from a function called I want to call a function like this. If I have a function called, let's say, print, then I want to pass this first pointer and then the data 6. Right, so let me create that function here. It's going to be I don't want this function to return at this point. Void print, and then generic type gptr and pointer, and we want to have int a, parameter values, parameter int b. So like in the previous case when I was talking about passing the data into a function using generic pointer, I also need to know which type of the function is being actually passed here. So for that purpose, I again want to create a enumeration just to represent the different categories of function. I would say I will call this function as a of one category, another category, third category. So I will have enumeration like this. Function category, let me call this function cats, category 1, category 2, category 3. So I would be having one parameter here to receive that type, function category type. Call this fc, and I will put this fc in the switch statement, and if it is cat1, I would call it using this syntax. So you actually reinterpret to this type, and this is going to be gptr, and the data you want to pass is a. But in this case, we have to make sure in the first case we have to make sure that we don't require, if it is a category 1, we don't require because this function takes only one argument, so we didn't require this second argument to be used in the invocation. So maybe you can set this to some default value. In that case, you can call this function with only these three arguments for these three parameters. Then we have a break statement and case. For second category, I would be invoking in this way. So gptr and then a and b. Case function cats cat3. In this case also again I will be having this kind of statement there. So AB, and this is gptr. So this is the code. This is the function that I am using, and in the first parameter, this is a generic pointer, so which has been used, but it has been casted into different types based on the value carried by this funcats object fc. So when calling this, you would be passing the first pointer, and then you will be passing this value, which is cat1 and 6, we don't, in this case we don't need to pass another value because we have a default parameter set to it. So this 0 will be used in this b, and in that case this b is not used here, so it should not be an issue. Let me call this function for a second case, gptr2 cat2. In this case the data I pass is, I think it's 7 and 8, so 7 8. This is going to be 8 and 9. So you call the function like this, but you're passing different pointers. Let me see this in execution. So now it is looks like it is working. In the first case it displays 16, like in this case. Second case 15, and these two lines with value 17 in the third case, like this. And you can also, instead of using this pointer, it's also put, because this actually receives a void pointer, so you can directly pass the name of these functions there. So it could be, just let me copy and paste here and pass sum1, sum2, and sum3. Oh, I think there was a small issue here. Let me go back and fix it. You need to cast, right? So when I actually use this, actually I did cast it using this this casting operator. So when you pass this function directly, you need to cast to void type. So now you can see this working here. This was the outcome of those last three statements. So we have the code here. Thank you for watching this recording on generic pointer.